In this video, we're going to go through the startup, commissioning, initial configuration, and menus of the NHX and N3X series inverters from Watts247 and Amensolar. This will include the 8K, 10K, 12K, and 16K models with and without the integrated breakers. So hang on for a step-by-step configuration and walkthrough. For most inverters, there is a standard startup procedure, so we're going to go through that to get the inverter turned on. The first thing that you want to do is connect the batteries. Whenever connecting your batteries to your inverter, you always want to make sure that you pre-charge the capacitors in the inverter. This is very important because even small batteries can cause a large spark or an arc when you connect to the terminal here. So to prevent that arc, which can get very extreme to the point of sometimes even welding terminals together, you want to use a pre-charge resistor. Some of the newer batteries come equipped with a pre-charge resistor. You'll have to check your documentation. This battery did not, and since I don't have a resistor, I'm going to use a trick, and that is a carpenter's pencil. So the graphite in the pencil works as a resistor. Now, when connecting the battery for the first time to the NHX, even with everything off, the LCD screen will come on once the capacitors are fully charged. As you can see, my battery is off now. If you're working with a single battery, it just needs to be off. If you're working with a battery bank, make sure that all of the batteries in the bank are off and only turn on battery 1. We want to reduce the amount of current flowing in to our inverter. Now, the first thing I'm going to do is turn on my battery. Then I'm going to take my resistor, in this case this carpenter's pencil. I'm going to first touch it to the terminal. Then I'm going to touch the cable to the lead on the pencil. You may see a small spark when you do this. Now we're going to listen for the inverter to power up. We should hear a beep and the LCD screen should come on. Once that happens, you want to hold for about another 10 or 15 seconds to ensure that the capacitors are fully charged. Once the capacitors are fully charged, you want to move as quickly as you can to touch your battery cable to the terminal block. And there we go. The next step is to press the RSD button on the inverter. Some other inverters just may have a standard power button, but you press this button to activate the inverter. Next, you'll want to turn on the solar panel arrays, turning on the PV disconnect. The next step, if your inverter is grid tied, you want to turn on the grid supply breaker. Also, a tip, most breaker panels, the manufacturer will make a surge protection device. This is a Type 2 surge protection device that I have installed in the panel and connected to the neutral bar. This protects all the devices in this panel from surge instead of having to put individual surge protection devices on each one of my devices down the line. These are about $40 to $60 online and on eBay. They will help to protect your inverter, which could cost thousands of dollars, from lightning strikes and surges through the municipal utility connection. When power is supplied to the panel, you'll see a light indicator come on the surge protection device in the panel, indicating that the panel is protected. On most of these devices, if that LED light is flashing, the surge protection device needs to be replaced. The last step is to turn on the loads for your inverter. This breaker protects the load side of my inverter. These breakers are for the loads. As you turn on the different supplies going into the inverter, the battery, the grid, the solar, and the loads, arrows will begin to appear on these lines and show you the direction of the flow. As you can see, we now have grid connectivity, but because there's no load on the house right now, no power is coming in. But it does show that we have connectivity. We also have connectivity to the battery. We do have an error, BMS COM fail. This is because we do not have communication established between our battery and the inverter. We'll address this later. Now we're going to go through the initial setup process. First, we're going to touch the settings cog. We're going to enter the password. The password is 5 ones. And touch OK. The first thing we're going to do is set the date and time. So we're going to use the scroll arrows here, and we're going to scroll through the setup menu until we reach date and time. So we're going to set our year, our month, and our day. Next, we're going to set our time. The time is in 24-hour format. It's very important that you remember that and enter the time, especially the hour, in 24-hour format. If you're curious what that is, 1 p.m. would be 1300 hours. You just take whatever your standard time is and add 12 to it. In this case, we're going to input 19. A minute is going to be 4, and our seconds will be 0, 0. And then we're going to hit the save icon at the bottom of the screen. It's important that you press save on every screen that you make a change to. Now we're going to press the scroll button and move back to our main system settings page. For basic off-grid setup, we're going to use self-consumption. We are going to keep backup enabled and keep that box checked. As long as you keep this checked, in the event that the grid and the PV are unavailable, the battery will supply power to all of the loads. Think of this as kind of a UPS mode for the inverter. It's a best practice to keep this on so that you have an uninterruptible power source to your home. If you disconnect this and the grid and the solar go out, then you will lose power to your loads. We are going to ensure that cell enable is unchecked. Many times with the system, it will come in default with it checked. This is as long as you disconnect cell enabled or uncheck the box, it will not sell back to the grid. We're going to set our grid export limit to 0. This is also going to ensure that we do not send any power back to the grid. This is an initial configuration for basic off-grid setup. Self-consumption sets the inverter to be your own power grid. It manages the PV arrays, the batteries, the grid, and the generator input to provide power. Self-consumption will prioritize loads and, when configured correctly, can also grid feed and grid sell. My setup, I do grid tied. Grid tied means I do pull in power from the grid and I use that with the inverter to mitigate the demand from my loads. However, I do not grid feed, which is I keep the inverter configured to ensure that it does not feed back electricity to the grid. Peak shift, just to go over the other options here, peak shift, if you have peak and off-peak rates, you can set those times here. For instance, you could charge your batteries in the off-peak times at the low rate and use the batteries during your peak times, which would be a higher rate. Battery priority prioritizes keeping the batteries charged to be available when the power is off and solar is unavailable. If the batteries are 100%, they will power the loads. Make sure backup enabled is selected to ensure if the power is off that the inverter will use the battery to power your loads. We're going to move over to the advanced mode. If you choose any of these advanced modes, the inverter ignores any settings for work mode. Advanced mode overrides work mode. We're going to go over limit consumption, sell first, and zero export. Sell first prioritizes selling power to the grid. You have to enable it, and once you do that, you can use additional settings like time of use, grid charge, PV first, battery first, and you can use CT power limits to set the power limits from the current transformers. Limit consumption feeds power to the grid, charges the battery during specific times. If you're selling to the grid, check sell enabled if you're using limit consumption. If not, uncheck it, and that will override the grid export limit. You can use limit consumption with net metering and grid sell. The last one is zero export. If you select zero export, the inverter will work to ensure that no power, no matter what other configuration settings you have, is sold back to the grid. Now, you always want to make sure you have a meter and you check that, but that is what zero export does. When selecting zero export, one thing to note, it is a small touch panel. If you have big fingers, you have to be careful where you touch the panel. When selecting zero export, that allows us to use advanced settings. That's where we'll find time of use and other advanced settings. We'll come back to this in a moment. I'm going to go to the next page, and that's going to be PV type. For most use cases, the PV type will be set to independent. This allows the inverter to manage the 4 MPPT charge controllers independently. So, for instance, if one array is producing 1,000 watts and another array is producing 500 watts, you'll get 1,500 watts. This can happen, for instance, if there is shading on one array but not shading on another, or if you have an array mounted on one side of the peak of your house and another array mounted on the other. Normally, you would have to use some external device to manage the differences in voltage because the arrays would either be shaded or receiving different amounts of sunlight. That is what makes the independent PV type very useful in setup. You can use parallel. The parallel setting combines all MPPs to act as one single MPPT controller. Now, you can do this if all of your panels are the same specifications, will not have any different shading, they have an identical orientation. If all of those things are true, then you can combine them and you may get some additional efficiency out of the array. However, keep in mind that if you have any shading on any part of it, it will drop the voltage in the output for the entire array. If you select constant voltage, this will set a constant voltage across all the MPPTs using the lowest voltage produced. This disables all the dynamic functionality of an MPPT tracker, and it does not adjust for maximum power settings. It can be used in some very simple setups such as battery charging only, or some integration with other older systems, and running diagnostics if there's some problems that you are having to trace down on your array. In most use cases, constant voltage is not used. Arc enabled. So the arc enabled setting is used to detect DC arc faults in your array, primarily from solar panels, maybe bad connections on your MC4 connectors. In some areas, arc enabled is required by code. Now, challenges can arise from enabling arc detection if you have a lot of lightning, thunderstorms in your area, if there's grounding issues, or if you have different soil moisture levels. Soil saturation can affect the conductivity of the soil, and if the soil is highly conductive, the inverter could detect voltage spikes from other grounded devices in the soil. Keep that in mind and check your local codes if you need to enable arc detection. Beep on and off actually does not turn off this beep. If you tick that, it will turn on a constant beep that beeps about every 3 seconds to let you know that the inverter is on and alive. It's very annoying. Now you know. Auxiliary load on and off. There is a second AC output on the inverter. This can be turned on and off based on the battery state of charge. This is very helpful when output 1 is tied to your critical loads and output 2 is tied to non-critical loads. For instance, you could put a refrigerator, your well pump, and your furnace on output 1 as critical loads, but your TV and microwave, all the rest of the power in your house, could be on load 2, and if there's a power outage, if your batteries drop, let's say, to 80%, it simply turns off all those other loads and keeps power going to your essential loads. Another great application of this would be for EV charging. You could set up an EV charger on load 2, come home, plug in your EV, and let it charge at night, and if once it gets the batteries, let's say, down to 60%, it stops charging the EV and leaves a reserve in your batteries for overnight for powering the loads of your house. You've already set the date and time. Peak shift. So on the main menu, we talked about peak shift. If we go back one menu, this is where you can set peak shift. If you have on peak and off peak rates. So you can set the time during the off peak to charge your batteries and then set the time when peak rates start to discharge the batteries and use the power that you stored overnight to power the loads in your home, not having to pay peak rates. So we're going to go in and take a look at time of use. Go into advanced settings. Now by default, you'll notice that the start and end times for each time of use entry, where we have 6 different entries, end and begin at the exact same time. You actually don't want this. So the first thing to go in and do if you're using time of use is to set these at 0, 1. There we go, and we're going to hit save. To enable time of use, you have to make sure that you are utilizing one of the advanced modes. Time of use, even if you enable it in the submenu, will not work under system settings in the basic work modes. If you have battery communication, you can just simply set your state of charge. You can indicate whether or not you want grid connectivity during those times to charge the battery, and enable your time of use table. After we complete battery setup, we'll revisit time of use to go over some additional settings. So we're going to save these time of use settings for now and go back to the main menu. When going through the setup process, after you have set your system settings of how you want the inverter to work, and we're going to go back and save this so that we're set up in basically an off-grid mode. The next step is to set up your batteries. We're going to go to battery, and we have 2 battery types. By default, the system will default to lithium. You have 2 types of communication, CAN and RS485. The inverter seems to like the CAN setting better than the RS485 setting. Once you have set lithium and you've made the connection, you want to ensure that your batteries are compatible with the inverter. Most batteries have settings in them to help you select a compatible communication type. You can use Pylon Tech or DEYE or die to communicate with the inverter. I'll flash on the screen the communication type that the inverter prefers. Next, we'll cover battery setup. There are two primary battery types that you can choose from: lead acid custom, and really this should just be labeled custom, and lithium. If you choose lithium and your battery has CAN communication, you can simply plug a standard Cat5 cable between the battery and the inverter into the battery COM port on the inverter, and by default most batteries will go ahead and communicate and work. If not, you can try setting your battery on your battery screen to a different communication type. So currently lithium is selected. We have CAN as the battery communication type. We have our charge current, and we can set this up to a maximum of 190 amps. That is what is on the specification tag for these inverters, and if you set it higher, the inverter may act strange and do some strange things with charging, so make sure you do not exceed 190 amps. For me and my setup, we're going to charge at 20 amps. For the discharge power limit, this is if you have the grid attached. If you set this, let's say, to 10%, this means that the inverter will draw 10% of its power from the batteries and 90% of its power from either solar or the grid. If you set this to 50%, then the inverter will pull 50% of battery power to the loads and then balance the rest of it between the grid and the solar. Now, if you do not have grid attached, it will simply balance the load between solar and battery. In my case, we're going to set this at 15%. Hit next. On the battery settings screen, underneath lithium, you have 4 options. If you are using custom, these 4 options are overridden by the custom settings at the top. Under lithium, you have low battery depth of discharge. This means the total depth of discharge. If you set it, say, to 80%, then that means there will be 20% of battery capacity left. So if I set the low battery discharge to 80%, this will allow, the inverter will allow the batteries to discharge to 80%. This will produce an alarm on the main screen letting you know you have reached your low battery depth of discharge. This setting, EOD historicity, allows for some give when you reach that 80%. So we're going to set that to 10%. We're going to set the low battery to 70. What that means is the alarm will go off that you've hit your low battery depth of discharge, but it will not stop the alarm until you reach 40%. So 70% here means there's 30% left in the battery. A 10% historicity means it has to get to 40% before your low depth of discharge alarm ceases. Shutdown depth of discharge, we'll set this to 90%. What this means is once it has discharged 90% and there's only 10% left in the battery, then the inverter will shut down all of the loads. We have a 5% historicity here, so that means that it will have to charge up to 15%, so at least 15% of battery life before the shutdown can be overridden. Something to note is the CAN ID. This is set up when you use a lithium battery type and you have BMS communication with the inverter. You want to ensure that there isn't a conflict between this CAN ID and the CAN ID on the first battery in your battery bank. Ensure by looking at the battery's documentation and manuals that the DIP switches are set so that you don't have a conflict with the CAN ID. Many batteries in their instructions will ask you to set the CAN ID with the DIP switches to 0, and then the next battery is 1, and so on. Sometimes this can cause a communication conflict with the inverter. If you run into a communication conflict, you can double check the CAN ID. Now we'll go over entering a custom battery configuration. I'm going to select lead acid custom. I'm going to save that setting, and I'm going to move to the next screen. In my case, my batteries are a 15S configuration. As such, I need to do a custom configuration for my battery settings. We are going to set our float voltage at 51, our absorption voltage at 53.4, our battery cutoff voltage at 43.5, our over voltage protection at 54.7, and since we have 4 batteries, we're going to set our battery capacity to 400 amp hours, and we're going to hit save. Now this is for my specific battery bank. Like I said, I have 15S batteries that produce 48 volts instead of the 51.2 volts that you may be familiar with. And save. Now we'll go back to the main screen, and you'll see that the error for battery communication has been cleared. We have a 78.2% battery charge, and I'm going to check that with the charge state on the LCD screen on my battery. We'll go back into our menu, and we'll go to grid setup. Under grid setup, for most US setups, we are going to select split phase. This is standard 240 volts with 120 volts on L1 and 180 degree phase to 120 volts on L2. This is the most common US setup. This will give you 240 volts across both phases. If you select single phase, the inverter will output 230 to 240 volts AC on both L1 and L2. Any 120 volt load would be damaged if you connected them to the inverter in this mode. This mode is useful for powering 240 volt loads like a well pump or a water heater. You also can use 208 volts, which is 3-phase, when working in parallel mode to create 3-phase power. You can use the 208 volt setting when working in parallel to create 3-phase power. You want to just accept the defaults, save. We have grid protect parameters. In some jurisdictions, if you are using this with a grid tied or grid feed application, you may have to make some additional changes to the settings here. Next, we have our grid standard. We have the United States selected because that is where we are, but you can use other standards if you like. There are some special unique use cases where you may use a different grid standard and selecting a different region. American Standard Classification, we're going to use UL 1741. You may again have different rules for the grid standard where you are. This allows you to make additional settings. Reactive power, we have reactive power parameter. This depends on the country where you are and which country is selected if required by their grid. You want to just keep it on power factor if you're in the United States and accept the default. Grid function, accept the defaults unless there's a specific use case and you've been told to change it. You do want anti-islanding, you want to detect leaking current, and you want insulation detection. Next we'll cover the generator settings. This is where you can enable or disable the AC input labeled generator on the inverter. You can use other AC input types, such as a microinverter, in this AC input with some custom configuration. But For now, we're just going to cover generators. You can enable the generator. Then you can enable generator charge. This will allow, when the generator is started, for it to charge the batteries. You can have two selections, either manual mode or auto start. If the generator supports auto start, there are inputs on the inverter to automatically start the generator. You can do it once the battery voltage hits a certain voltage, and you can stop the generator once the batteries are charged up to a certain voltage. You can set the charge current. This is very important. The charge current here is what is used to charge the batteries from the generator. Make sure the generator capacity matches this charge current. Most common 240 volt generators in the United States are 5,500 watts. Well, if you divide 5,500 watts by 240 volts, you will get 22.9 amps. You also need to take into consideration conversion losses, and you don't want to run the generator at its max. So for a 5,500 watt generator, you would set this to approximately 18 amps. For a 3,000 watt generator, it would be about 10 amps. For a 9,000 watt generator, it would be about 30 amps. So make sure that the charge current you set here to charge your batteries matches the output of the generator. Max operating time allows the inverter to control how long the generator can run for. If you have a generator that does not support auto start, you can use this in manual mode. What you would do is select generator manual mode. You would then start your generator and let it start to warm up. While it's warming up, select generator manual start and stop for manual operation. Once you have selected generator manual stop, you would then plug in or turn on the breaker to your generator. This gives you about 10 minutes before the loads will fully connect to the generator and start to charge and power the system and the battery. Now, because it's in manual mode, it will work with the stop volts and the charge current, and the inverter will do that, but you have to remember that because it's not connected to the generator, a max operating time would not be applicable. In some special use scenarios, you could connect a second AC input to the generator input on the inverter. You would select generator manual mode, set the start and stop volts, set your charge current, and the watts. Now, where this could work is if you installed another solar array and you were using a grid-tied inverter or a microinverter that just simply converts the DC power from your array directly into 240 volt electricity, you would have that as an input, and that input could then charge your batteries, multiplying the size of your solar array. You want to make sure that you understand the ramifications of that setup and that you've done plenty of research to ensure you know how to make those connections without harming yourself or damaging your equipment. We're going to go back to the main menu, and we're going to go through and do some custom configuration for a grid-tied setup based on my setup. I'm going to go back into advanced, and we are going to go into advanced mode. We are going to select 0 export. We don't want cell enabled. We're going to save this setting, and now we're going to go into advanced settings. Now, what I want is during my peak usage time, which is between 4 p.m. and 9 p.m. in most areas in the United States, we are going to allow the use of our batteries during that 4-hour time slot. What we're going to do is we're going to go to our 4th time slot, and we're going to change the 15. Remember, we're in 24-hour time here, so we're going to change this 15 to 16. That would be 4 p.m. And we're going to change the 15 here, which is currently 3 p.m. to 16, which makes that 4 p.m. 2100 hours is 9 p.m. So between 4 p.m. and 9 p.m., we're going to allow the batteries to be discharged to 48.5 volts. This will let it discharge 30 or 40%. We're going to hit save, and we're going to enable time of use. Now I want to show you something here. This is very important in time of use when you do these setups. If I just put 53 and hit OK, it won't do it. It needs 3 digits entered here, so we want 53.2. It also doesn't like the decimal point. So you always have to make sure that you enter 3 digits. If we wanted 53 volts there, it would have to be 530. Notice, because we are using a custom battery type, instead of percentage here, it's in voltage. We also have grid charge enabled for all of the time slots, and battery power. So this is the total amount of watts that the battery can produce. Now, keep in mind that how you would figure what the watt capacity is of your battery is your batteries are generally 51.2 or 48 volts. Mine are 48 volts. They are capable of producing a constant discharge of 100 amps for a total of 4,800 watts. That's for one battery. Now, since I have 4 batteries, I can produce significantly more than that, but I'm mitigating the amount of stress that comes out of the batteries for this charge cycle. So I've chosen to just leave it at 72. I'm going to hit next. So in advanced settings here, when you're using any of the advanced modes, you can set how you want the inverter to prioritize what it does with the electricity that comes in from the grid and from the array. Right now I have grid charge enabled. What that means is the solar array will charge the batteries. If the demand for the load exceeds the array and the batteries still need to be charged, then it'll allow the grid to charge the batteries. If I deselect this and select PV charge only, the only thing that can charge the batteries is the solar array. So if during the day, let's say overnight, I've depleted my batteries to 50% and it's a cloudy day the next day and they may only charge back up to 70%, well, when we get into the next night, the batteries will only be at 70%. We can also set it for PV charge only and battery first. As long as you have battery first selected, it will divert all power to charging the batteries first. Once the batteries are at 100%, then the inverter will power the loads. In my case, I want grid charged, and I want to allow the inverter to simply manage what gets charged and what gets powered with whatever the input is coming in from the solar, the battery, or the grid. CT power limit. If you are set up for grid feed, you can set how much power can go to the grid from the inverter. So for instance, it's a 10,000 watt inverter. Let's say you only want to feed 5,000 watts to the grid and have 5,000 watts available for load. If you were feeding the grid, you would set that limit here at 5,000. This allows you to mitigate the capacity that's available when doing a grid feed. In my case, I don't want to feed anything to the grid, so we're going to make that 0. Save. Next. If we were doing a grid feed, we would set this grid historicity to 5 or 10%. Because we are doing no grid feeding, mine is set to 0. Let's go over the main screen and what we'll find here. First thing, in the top left, you'll see an icon for the solar array. It's about 8 o'clock where I am right now. So the sun is getting ready to set. So we're not pulling in a whole lot of solar, but we do have some solar coming in. Oh, about 200 watts. You can see the different arrays. Right now I have 2 arrays hooked up, PV1 and PV2. We'll be hooking up the other 2 arrays later on. You can see that we have the total energy that is produced in a day and total for the inverter. And right now, because we just set the inverter up, we don't have any totals to report. Back to the home screen, we can check out the battery settings. our current voltage is, how much is being pulled in amps, the state of charge for the battery. We don't have comms, so temperature isn't going to report. We're currently drawing about 100 watts out of the battery, and our battery type is set to lead acid. Remember, this is also custom. We have our charge voltage, our charge current, and our discharge current. These settings are overridden by the settings in the setup menu of our total charge and discharge for the day and for the totals. You can also see the inverter state. So right now we are using PV grid. The inverter state is grid. DC to DC state is discharge because we are using battery power. L1 is at 120 volts, L2 is at 120 volts. We're pulling about 1 amp on both and about 100 watts from each side. We can look at the grid supply. So our grid frequency is exactly 60 Hertz. Coming in from the grid on L1 we have 121.4, L2 we have 120.7 volts. You can see that our draw from the grid is 3.5, 3.4 amps per leg, and we're using a little bit of 20 watts or so on each leg. And no totals for the day. You can look at the generator settings. Currently we're not running a generator and we don't have a generator connected, so there's nothing really to report there. But you can see the frequency, the voltage, the current, and the power in watts being input by the generator and what would be used if we had a generator hooked up. Lastly, we can check on the home, and this would be our load. Right now we're pulling 122 on L1 and 121.5 volts on L2. Current, again, about 2 amps per, and we're just barely pulling any power on each leg. My loads are at idle right now. Keep the noise down for our video. Go back to the home page, and it is a nice screen, easy layout, easy to understand. You can see with the directional arrows where the power is flowing to. So we have 100 watts coming in from the solar. We're pulling in about 100 watts from the battery. Not really pulling much in from the grid right now, and all of that would be going into the house. Now, if we wanted to, say, charge our battery, what we could do is go into settings, go to our advanced settings in time of use, and change our time slot to 53.2 volts. So here we go. We're going to make that 53.2. We're going to click OK. We're going to hit save. We're going to go to our home screen, and now the battery is being charged by the grid and by the solar based on our 20 amp charge rate, which is about 1200, 1300 watts. So we have 1 kilowatt going into the battery, and you can see it's pulling power in from the grid, it's pulling power in from the solar, and it's pushing it into the battery. If you were doing a grid feed setup and you were feeding back to the grid, you would be able to see the directional arrows going into the grid if you were sending positive electricity back into the grid. Now we'll go into our battery settings, and we can see now we're charging at 20 amps and increasing the state of charge of our battery. The home page. If you touch an icon and you want to go through without going back to the home page, you can simply touch an icon up here and move to battery, inverter status, load status, grid status, and generator status. Go back to home. We're going to go to settings, advanced, and we will reset our parameter for 4 to 9 p.m. back to 48.5 volts. So we're going to do 48.5 and save. So now we'll see the battery change, and we have discharge from the battery. If you have any questions, put them in the comments below, and I'll try to get back to you as quickly as I can. Thanks for watching, and have a great day.